Okay, good evening, everyone. Today we're going to continue our discussion on multiple linear regression. We started with the concept of linear regression. We said that the objective is to find a relationship between your variable of interest, your dependent variable, and try to explain it or associate it or create a model using your dependent variables. Okay, so we loaded our wage data set. So very quickly, let's take a look at what's inside our data set. Okay, let me just write it here. Let me just write it in the console view, wage. Okay, so we have 3, 4, 5, 6, 7, 8 variables, of which one is your dependent variable, hourly wage. And if you take a look at let's have a quick review of the structure of the data. Okay, so let me just write it here. Control Alt I. Okay, structure of wage. This will give us information about your data. It's a special table. Okay, it's a data frame. You have your numeric and your character variables, tenure, race, gender, and civil status. And we said that we would like that the character variables be converted into factors that can easily be done by, okay, Control Alt I again. So wage, sorry, we have our data wage, dollar, the race alt minus, okay, alt minus, then we want it as that factor. Okay, factors are different from character variables. Factors are a special type of character variables because they can be used as classifiers. Not all character variables can be treated as factors, but all factors are character variables. So as that factor, wage, dollar, then race. Okay, there you go. So we're converting this data, the race variable, into a factor. We can do the same for wage, dollar, gender, alt minus, as that factor, wage, dollar, gender. Okay, and then lastly, oops, sorry, I run it. Shift enter, wage, dollar, and then civil status, alt minus as that factor, wage, dollar, civil status there. Okay, so we have 3 variables that are character variables, which can be considered as factors because they can be used as classifiers. So here, for your race, gender, and civil status, I think last time we used okay, let me put it here. Okay, Control Alt I, and then table, wage, dollar, race. You can have here a frequency count of the different levels. You have 2 levels here, non-white and white. Okay, and you can do the same for your other character variables, wage, dollar, gender, and wage, dollar, sorry, table, wage, dollar, okay, civil status. Okay, if I run this, okay, may I know, class, if we did this last time, if we check the different levels of your factors of your categorical variables? May I know, class, please? Because I might be assuming, and then I might be going too fast already. Did we do this last time, class? Did we check what's inside our character variable race, gender, civil status? And here it tells us that there are two levels, non-white and white.
Yes, sir.
We did that last time. Okay, good. All right. So that will serve as a quick review. Now, when we just again, what we did a while ago, we got the structure of wage, and we saw that the three, okay, okay, we have race, gender, and civil status. Now, it turns out that I think I converted this already, but character, these are character variables. So if we convert them into this one, into factors, okay, I'll run everything here. And then we run structure again, structure. We'll now see that they are now converted into factors with two levels, and two levels. Okay. Let me pause for a while and wait for your feedback if you were able to convert your character variables into factors. And your feedback, please. You're done, class. Kindly please chat yes. Okay, thank you. So wait for the others. Okay. All right, good. 1, 2, 3, 4. We are 7 here. So waiting still for the 7 others to the others. Okay. Okay. All right. Good. Thank you so much, class. Okay, now let's go to our first regression model. Going back here, we said that the purpose of multiple linear regression is to establish a relationship between your variable of interest, which is your dependent variable or response variable, with your explanatory variables or IVs. So if you only have one independent variable, there's only one variable that you're using in order to explain your dependent variable, then we have what we call a simple linear regression. Okay. Here, simple linear regression here. So a type of linear regression where we use one explanatory variable or independent variable, explanatory variable, or this is your IV, independent variable, to explain the dependent variable. Okay, so one independent variable. Now, last time, we did a pairwise comparison. So we created this object wage1 where we eliminated the factors. Okay, let me do this, class. Control Enter. And then let me run this. We ran this last time using GG allied GG pairs. Okay, then that will show now your here. Here, class. This is our correlation matrix. Okay. And by way of review, we said last time that we would want the dependent variable to be highly correlated with your independent variables like education, experience, tenure, number of dependents. Now, if you were to perform a simple linear regression model of these variables here, number of dependents, tenure, experience, and education, the best quantitative predictor will be education, because by virtue of having the highest correlation among the different variables. So that can be validated, that can be checked, but we're going to use that first. So this will be our first linear model. Okay. So how do we write our linear model? We're going to create this object mod1, okay? And then this is our assignment operator, as you know. And then we're going to use the LM function, linear model. And how do we write the regression model? You start with the dependent variable hourly wage, and then this is tilde. Okay, this is coming from the either use shift 6, no, shift and then the tick symbol. Okay, this stands for is associated with or associated with. So you're associating hourly wage with education, and then we define the data. Where is it coming? What data are we using? We're using the wage data set. Okay. In the notes, I didn't provide this, right? Am I correct, class?
Yes, sir. No po.
Okay, so I want you to write it, class, so that you get the feel of writing your regression model. So just write this first. Okay, and when you're done, class, we're calling this mod1, model 1, LM, linear model. We're associating hourly wage, our dependent variable, with your independent variable eduk. Okay, we're only using one independent variable. That's why this is what we call a simple linear regression. And we define the data. Our data is our wage data. And when I run this, Control Enter, I go to this line, Control Enter. Okay, notice now that there's an object in our environment here, mod1. Okay, and if I print what's inside mod1, you can see here, this one tells us that it's a list. Okay, and what's inside this list? There are 12 objects here: coefficients, residuals, effects, repeated values, QR, call, etc. So there are 12 objects here: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Why is there coefficients, residuals? Anyway, okay, list of 12. Then you have here the coefficients. If I click this, it will give you the intercept and the education and the value of education. You have here the residuals, okay, etc. So these are the objects that are found inside mod1. So we can access several information here. Going back here, if we run this function summary model 1, okay, I'll give you some seconds to run this function summary mod 1. Kindly run that and let's see what happens. Can you tell me, class, what's inside the summary of model 1? What do you find inside here, model 1? Anyone, please? You'll find your okay. First, did you get? Were you able to run summary model 1? May I have your confirmation if you were able to run? Okay, thank you, Angel. How about the others? Okay, thank you, Dom. Hannah, thank you. Nick, thank you. Okay, Michael, thank you. Right. Anyone having a problem with this function summary? Okay, if I run this class, control enter, you'll see that it prints out the results of your regression model. Where is that? Okay, there. Okay, so this is the result of of summary model 1. First, you have the formula that was used in generating this output. Okay, you have LM, and the formula was hourly wage associated with education, where data is equal to wage. Then you have here some information about the residuals. As we said before, the residuals are the deviations, okay, the discrepancy or the difference between your observed value and your predicted value. Because as I said last time, this is your observed value for hourly wage, predicted value, actual value. And then when you have the model, you'll have what we call the predicted value or model value. Okay. In fact, here, class, this one, fitted values. Okay, what do you have here? For observation number 1, okay, the fitted or the predicted value is 5.05. Okay, this means that when we run the model, when we use the model that was generated and compute for hourly wage, this was the value that we obtained. So this one is to be compared with your actual value. Your actual value is 3.10. So 3.10 actual observed minus 5.05, the model value. Okay, so let me get that. 3.10 minus this one. So we can do it this way, class. Okay, let me show you how we can do it. It's coming from model 1, right? Dollar, fitted values. Okay, that one. And then I'm getting brackets 1. So that's the first value of our fitted value. Okay, so this is the observed value, 3.10 minus mod 1. You have here the predicted values, and this is the first one. Okay, why don't I write first this one? Okay, control enter. There you go. This is the first predicted value, and then 3.10 minus, again, let me just copy this, control C, control V. Okay, you'll get this one. So this is the residual, the first residual. And you can get that by, okay, so model 1, that's our model, dollar. We have here residuals. Yeah, residuals. Okay, and then I just need the first one. What's the first residual? The first observation. Control Enter. There. Exactly the same. Okay. So that's our, okay, where's that? Here. These are the residuals class. This is what I meant, information about the residuals. What's the minimum residual? Okay. Maybe let's use that. Minimum, okay. Minimum of model $1 residuals. Okay. Let's get the minimum among the residuals, and we expect it to be this one. Okay. There you go. And then you can get the median, first quartile. You can also get the max. Everything here you can get by a formula. Okay, so let me pause for a while, class. These ones are very easy to obtain. Okay, just because our Model 1 class, as I mentioned a while ago, it's a list. Okay, you have here many information, many data. Okay, all right. Let me pause for a while, and may I ask you, class, if these are clear? We were just looking at the regression output. Okay. Do you have any questions about that?
Sir, question. How
Sure.
come my summary appeared on the console and not where yours is po?
The console. Sige. May I
Ay,
share ako, ah? Sige. Can
so,
you share your
so
screen?
hold on lang, sir. Apologies.
Sige.
Wait lang po.
It's okay. It's okay.
Sorry, I'm using another laptop lang po.
Oh, sige, sige.
Uh,
Okay. No problem, no problem. We'll wait.
hold on, hold on.
Hmm.
Shucks. Can I?
Take your time. Don't panic.
Sorry, sir. Hold on.
No, it's
I
okay.
just
It's
have
okay.
to log in Zoom in the other laptop.
No need to, no need. Ang suspicion ko dyan, baka dun mo irinan sa ano, where did you run the code? Sa,
Uh,
sa source window o sa console?
sa source window po.
Sa
Pero
source. Okay.
lumabas po sa console
It
yung...
will also appear in the console, ah. But
Yes po.
it should
Pero
appear also in the source window. Sige, let's see. Tingnan natin.
Mhm.
Yeah, okay. Okay, Jet, we'll deal with that later, huh? Okay, if I mark you absent, I'll after class na lang, ha? Balikan natin attendance. Thank you, Jet.
Welcome po, sir.
Okay.
Sir, may question din po
Sige,
ako.
sure. Go ahead, go ahead. Sige.
Sir, yung mga recordings po natin, hinahanap ko po kasi sa Canvas po para po sana ma-review ko yung mga recordings from our previous classes po,
Ito, hindi
previous
dito lahat, ha? May screen i-share. Ande, share ko yung screen ko, ha? Okay.
yung ano po sir, yung 'di ba po nagre-record po tayo ng ano, ng sessions po natin every class po.
Yes.
Parang wala po kasi siya sa ano, sa Canvas po.
Nasa modules ito.
Nasa
Oh,
modules.
nasa modules lahat 'yan. Oo.
Okay po.
Everything is
Thank you,
there. Okay, so
sir.
if you want to review, andyan siya. It's in the
Yes po.
modules. Okay.
Okay po. Thank you,
Thank
sir.
you. All right. Thank you, Jet. Hintayin natin si Angel, no?
Here po, sir.
Okay, sige. Okay. All right. So lumabas it appeared in the console. That's good, no?
Yes po.
So
Pero
dito
it's
sa
not
ano,
here.
okay. May I see, so may mod 1 na tayo, di ba? Sa environment mo, andyan si mod 1.
Ito po, sa baba. Yes po.
Good, no? Tapos, could you kindly run again si summary 1? Control, punta ka lang kay summary module 1. Nasa ilalim. Angel, nakita ko na kagad yung call, no? It's there. Under.
Okay. Ito po.
Andyan siya. Oo, andyan siya. Oo.
Okay po. Sige po.
Okay, good. Sige.
Okay.
Okay, thank you. Thank you, Angel. Sige, share ulit ako, no? Okay, so let's go here. Asan na yung R ko? Okay, all right. So what's important in this output is that we should know how to interpret this. Kasi sa paper nyo, okay, so may regression kayo, no? It's not enough that you generate this kasi madali lang yan eh, yung LM. Madali lang siya. Ganyan lang siya. Oh. Sa research, sa paper nyo, you'll have to explain ano yung meaning nito. So let's start with a basic one. Ito, no? Itong coefficients na to, class. This one can also be obtained dun sa ano natin. Kasi ito, class, itong coefficients na to, andito yun sa model 1 natin. Here, coefficients. Diba? Andyan si intercept, yung value na yan, at saka si education, 0.541, andito siya. Yan, exactly the same. And you can print it here. For example, mod 1, diba? Mod 1 yung model natin, dollar. There, dollar. Coefficients. Si coefficients, dalawa yan. Okay, so again, kung gusto ko lang yung una, so bracket 1, that will give us the intercept. Okay. If I want number 2, the parameter, control enter, that will give us the beta or the parameter for education. Okay, so let's interpret this. Ito yung model nating class, no? We want to model hourly wage, okay, using education as the parameter. Okay, so if we write the equation, we have the dependent variable hourly wage, okay, is equal to, the generic formula is beta null plus beta 1 times your variable education plus a certain error term, epsilon sub I. So this is the equation that you need to set up. If we're going to set this up, so meron tayong hourly wage is equal to, this is our intercept, and our intercept is negative 0.9045. I'll just round it to 2 decimal places. 0.90, okay? Negative 0.90 plus, okay, sorry for the overlap here, 0.54. Just 2 decimal places. I'll just use 2 decimal places times education, okay, plus a certain error term. Okay. So this is our model class. Okay, and then I said, class, that hourly wage is an observed value, right? Ito siya, di ba? Ito yung wage natin dito. And the first observation, as we said a while ago, is 3.10 yata, 3.10, right? It's 3.10. And this one, class, this one, yung beta null natin plus beta 1 times education, this one, this is your fitted value or predicted value. Fitted value or predicted value. Okay? In the output in model 1, it's called fitted value. Now your observed value, okay, this is your observed value, 3.10, and your fitted value, which is, our fitted value is yung 5.05, di ba? Hindi sila equal. Okay, they will not be equal more often than not, no? Ang observed value natin 3.10. For observation 1, I'm talking of observation 1, yung unang ano natin, yung unang data natin. 3.10 yung observed value. When we use the model to come up with the value, okay? So let me just show that, no? Kasi could somebody please tell me what's the education? How many years of education does observation 1 have? How many years of observation does he have? Sa data, please, ilan? Ilang years of observation? Ilang years of education? Ano ko nga, clear ko muna. Ito. Okay, dito class, no? Take a look at this. Yan. Education na 11, di ba? Ito yung observed value niya. Okay. So, what we do, class, so that you understand what's happening, kasi importante na intindihan natin eh. Yung equation natin, hourly wage is equal to yung, okay, nawawala na naman. Ibalik ako dito. Ito, class, no? This is our beta null, beta 0, plus beta 1 times, this is our beta 1. The estimates are our betas. Okay? So if we, kokopyahin ko to sige, gawin natin yung ito, class. So this one is the intercept, right? Negative 0.90485. And then I'm going to add plus, okay? This one, control C, control V. Ano to, class? Ito yung 0.54136, di ba? Ito yun. And then I'm going to multiply this by education, no? Education. Okay. I can do this, class, wage, dollar, education. Okay. And then yung pangalawa, no? The second one. The first one pala. Sorry. There. So kita nyo, class, this is coefficient number 1, which is negative 9.0485, plus yung coefficient number 2 is this one. Okay? And then we're going to multiply it by, kasi this is education times the number of years of education of the first observation, which is, makukuha natin yan sa wage data set natin, dollar education, and then the first one. So if I run this, class, control enter, this gives us the first, ito na yung predicted value natin, 5.05. Diba? Yung kaninang pinakita natin dito, ito, class. Okay? And so, again, sabi natin, our hourly wage is equal to yung beta null natin plus beta 1 times education. Okay? And this is, class, your predicted value. No? This is your fitted value. Fitted value, this is your observed value. Okay? Now, for the first observation, our observed value is 3.10. Our fitted value is 5.05. So hindi sila equal. Now, to make them equal, we balance it with the introduction of your residual para maging equal sila. Okay? In other words, class, yung observed value natin, your actual value, minus your predicted value or fitted value is equal to your residual. Okay? Yung difference ng actual value and the forecasted value or predicted value is your residual. Okay. Pause for a while, class, and may I ask for your feedback, class, if maliwanag so far yung discussion natin about the estimates here and how is it used to in order to predict your value. Ang multiple linear regression kasi, class, ginagamit natin yan in order to, one of the main important functions or role of multiple linear regression is to predict, okay? Predict your dependent variable. Okay, may I have, class, your feedback, please? Waiting for your feedback. Kamusta naman so far yung concept na to? We're comparing the observed value with the model value, with the predicted value or fitted value. Hello, class. Hello, class. Hello. Feedback, please, class, before I proceed. Any questions, any clarifications? Or if it's clear, kindly please chat yes. Clear naman so far. Or need more time to try to write? Okay, Dom, thank you. Yung mga sinusulat ko dito sa console, you can, of course, copy this class and put it in your source window para, kasi sa console pwedeng mabura yan eh. How about the others, please? Okay, thank you, Nick. Okay, Hannah, thank you. The others, pag may question, please feel free to ask questions. Let's wait for the others who might be keying in, typing the functions also. Okay, sige, thank you. Okay, all right. Thank you for your comments, please. Okay, let's quickly interpret this class. Okay, first is the intercept. Now notice that the intercept is not statistically significant. Okay, this is 0.187. Now usually we use a p-value of 0.05 as your level of significance. A variable is significant if your p-value is not more than 0.05. Okay, so the p-value of your intercept is 0.187. So this means that this is not significant. Okay, in fact, the null hypothesis here, null for the intercept is that beta, it's beta sub 0 is equal to 0. So we're testing the hypothesis if your intercept is equal to 0. And the p-value here of 0.187 tells us that we fail to reject this null hypothesis that beta, that the intercept is equal to 0. So there's a strong statistical reason to believe that indeed your intercept is equal to 0. Okay, and then this one, education. The estimate is 0.54136. So how do we interpret this? This is interpreted as for every, education is in years, okay? In years to. So this one, 0.54, is the marginal effect on your dependent variable for every 1 unit increase in your independent variable. So let me state that in a more approachable term. So for every 1 year increase in education, notice I said year because the dimension of education is in years. So every 1 year increase in education, okay, will result into a 0.54, okay, dollars. Now why dollars? $0.54 because hourly wage is in dollars. Wage to it. It will lead to a $0.54 increase in hourly wage. Okay, and then we say ceteris paribus. I'll explain ceteris paribus later kasi in this case, it's not relevant kasi simple linear regression lang tayo. Ceteris paribus means all things being the same, which means that we're only going to increase education by 1 year, the rest remains the same. Okay, so let me repeat this class, this 0.54. This 0.54 means that for every 1 year increase in education, there's a corresponding $0.54 increase in hourly wage, ceteris paribus. And this one is highly significant. Okay, this is much less than 0.05. 2e to the negative 16. If you recall, what does that mean? So you write 2 and then move 16 decimal place to the left. 1, 2, 3, 4, 5, 6, 7, 8, up to 16. So it will be that point, decimal point, and then 15 zeros, and then 2. So that's a very, very small number. It's much less than 0.05. Okay. So, and if you recall, class, our cardinal rule, when the P is low, the null must go. Because the null here, okay, for this statistical test is that null hypothesis is that beta 1, so this is your estimate for education, is equal to 0. Okay, beta 1 is equal to 0. Now, with this statistical inference, we're saying that we reject this null hypothesis. Unlike the intercept, we fail to reject it. This one, beta 1, we reject that. We reject the null hypothesis that beta 1, which is the estimate, which is the parameter for education, we reject that it's equal to 0. Okay? In fact, the average value of your estimate for education, its effect on hourly wage is 0.54. This is the average. Okay? All right. Let me pause for a while, and again, I'd like to ask you, class, if the interpretation of the estimate is clear to us. Okay? Okay, thank you, Dom. Let's wait for the others. So requesting your feedback, please. On the interpretation of the coefficients. Any questions? Okay. Thank you. Thank you, Angel. Nico, thank you. Mike, thank you. All right. So I hope the others are able to follow too. If you have any questions, please feel free, because for some of you, this might be the first time you're meeting a regression output, and we'd like everyone to really understand and appreciate what this outputs are. Okay. Okay, so let me clear the drawings. There are some other things that are explained here. Okay. For now, let's just take a look at this one, the adjusted R squared. We're going to discuss the others. Okay, let me discuss also this one. Okay, as I said, class, this consists of a test, hypothesis test. For this, for the intercept, the hypothesis test is that your beta sub 0, which is the parameter or the estimate for the intercept, it's equal to 0. And this one also, for the education, beta 1 is equal to 0. Okay, then also, class, let's, I forgot to interpret the intercept. The intercept, class, is the average value of your hourly wage when all your predictors are equal to 0. Let me repeat that. This is the average value of your hourly wage when all your predictors are equal to 0. In our case, we only have one predictor. It's education. So we interpret it as it's the average hourly wage of a person who has 0 years of education. Okay, and the answer is negative 0.9. Okay, it's negative 0.9 class, and let me just say that we don't usually give practical meaning to your intercept. In this case, a negative 0.9 average salary hourly wage would mean that it is the employee who is giving to the company the hourly wage, which is absurd. No? So nobody can have a negative average hourly wage. But still, and even if this is not significant, class, we still include it by practice. We still include it in the equation. If education was not significant, then this would not have been included in your model. But for the intercept, the common practice is you still include that in your model, despite the fact that it's not significant. Okay, now let's go here. Residual standard error. Okay, so this is just, it's like the standard deviation of your residuals. Here you have your residuals minimum, maximum, first quartile, second quartile, third quartile. Another information here, okay, this is the standard deviation of your residuals, okay, and the degrees of freedom here, 524 degrees of freedom. So again, we have some parameters here, df, degrees of freedom, and for regression, it's equal to n minus k minus 1. Okay, let me explain this. The degree of freedom, okay, for your tests here is n minus k minus 1. What's your n? N is your number of observations. Okay, we have 526 observations for wage. Okay. K refers to your number of predictors. So how many predictors did we use in our model? We only used one, education here. So this is minus 1. Okay. And we have here another minus 1. Minus 1 is to take into consideration the intercept, okay, because we are computing for the intercept, so we also lose 1 degree of freedom here. So that's why the formula is n minus k minus 1. So it's 526 minus 1 minus 1. Hence you have your 524 degrees of freedom. Okay, 524 degrees of freedom. All right. Then we have here multiple r squared and adjusted r squared. I'll focus first on the adjusted r squared, 16.32%. All right, this is very important for us, 16.42% or 0.1632. Now, what does that mean? Imagine your data, your variable hourly wage of variable of interest, which is hourly wage, it's what we're modeling. Okay, imagine it's a circle like this, and here it has a measure of variability, variance. Now, 16% of this one, 16%, sorry, it's quite big, no? It should be only quite small, no? 6.1632, we say that 16.32% of the variation of hourly wage can be explained by your predictor education, by your model. Okay, 16.32%. The variability of hourly wage, 16% of that can be explained by this model. Okay, so what about the 83%? Well, it can be explained by other predictors. But as far as education is concerned, we can only explain 16.32% of that. Okay. All right. Then we have this one, F statistic, 103.4 on 1 and 524 degrees of freedom, DF. Okay, so we have the 2 degrees of freedom here for this one. And then I'm going to explain what is this one. So the degree of freedom 1 and degree of freedom 2. Okay, degree of freedom 1 class is your K. That's the number of your predictors. So it's only 1 because we're only using education as a predictor. And this one, degree of freedom 2, is the same as n minus k minus 1. N minus k minus 1. Okay? And then we have here a p-value. Okay, so this is the joint test of significance. But in our case, we only have one predictor, so this is just the same as null hypothesis, beta 1 is equal to 0. Beta 1 is equal to 0. Why is that so? Because this is what we call joint probability test. Okay, it's joint, but the thing is we only have education as our predictor. If we were using multiple linear regression, then we will have now beta 1 is equal to beta 2 is equal to beta 3 is equal to 0. Okay, all right, that will become clear when we go to multiple linear regression. Okay, so far class. Okay, so far class, how are this? The call it the anatomy of the regression output. Any question here, class? Or let me rephrase my question. Is it clear so far? Anything you want me to explain further? So kindly in the chat box, please kindly signify if you're able to follow so far. Okay, thank you, Dom. For the others, please. Please feel free to ask questions because we would want the main model that we're using for this subject is multiple linear regression. Plus, of course, we're going to have another model after this. Any questions, class? Or feedback, please, class, if you got it. Just want to be assured that you're not ashamed to ask questions. So I'll wait, class, for you to signify that you understand so far what we have been discussing. If you want me to repeat a certain portion of this, please tell me. No problem with repeating. Okay. Thanks, Nick. Thanks, Sana. Let's wait for a few more responses from your classmates. About the others, please. Okay. All right. Thank you. Thank you. Okay, let's now move on, class. Okay, so we have looked at the result of a simple linear regression. However, you can see here, class, that the adjusted R squared is very low. 16% lang ang kayang i-predict. Okay, so why not use also the other variables? So let's do that. I'll clear the drawings here. And then let's move on to the next one. Okay, did I provide this, class? These other formulas here. Okay, this is a formula on how to compute for the estimate for your beta 1. Okay, but we won't go there, class. We won't go to in how to estimate, how to compute for that. What's important for us, class, is this one. We were able to have this. This is not a subject on compute, learning how to compute for the some of the statistics, but rather what we want here is to understand the model, understand the output. Okay, so we'll now go here, class. We'll now go here. Okay, so I'm going to create now another model. Okay, let's change this. So we're going to create a full model. Okay, maybe let's call this full model. And your full model is your LM for hourly wage, and then education plus experience plus tenure plus race plus gender plus civ status plus depth number of dependents. Okay. Let me put some space here. That you can see it better. Okay, take a look now at our model, class. So we're regressing hourly wage on education, experience, tenure. Okay, and this is just the same as full model, and then LM, hourly wage, shift tilde, dot, data is equal to range. Okay, take a look at this, class. Let me print this first. Okay, full model LM hourly wage regress on this dot represents regress on all variables. So that's what this means, class. Okay, so it's just the same as this one. Hourly wage regress on education, experience, tenure, race, gender, civil status, and number of dependents. Data is equal to wage. Okay. All right. So let's run this, class. Okay, full model. Okay. I'll just comment this out. We'll just run this full model, class. Control Enter. Okay, let's see if we are able to generate. Here you go, full model, class. And then if I print this, again, it's a list. It contains your coefficients. Take note your coefficients now. They are now many. Okay, so we'll interpret this. Okay, and let's now print this summary, full model, Control Enter. All right, let me pause for a while, and once again, I'll give you a few minutes to run this, and then if you're done, if you have run it, class, please, once again, please chat in the chat box that you have run, that you got the output for our full model. Okay, waiting for your feedback, class. Okay, thank you, Dom. How about the others, please? Same result, Hannah. Thank you. Waiting for the others, please. In case you missed the code, this is our code. Full model. I use full because we used all the predictors last. Okay. Let's give your classmates a few more seconds, please. If you're done, class, if you got the output, kindly message, please. Post your message. Kamusta na iba, please? Okay, thank you. Angel, thank you. Jet, thank you. Okay, a few more seconds and then I'll proceed. Okay. All right. I hope everybody's got it, class. So let's now interpret this again. Okay, it's not enough for us to be able to generate the model. We have to interpret this. Okay, so once again, this is the formula. Hourly wage regressed on all your predictors: education, experience, tenure, race, gender, civil status. Now take note, you can use the factors. You can use the character variables that are factors in your regression model: race, gender, civil status. And then these are once again some metrics, descriptive statistics for the residuals. Okay, and then let's take a look at this class. Of all the predictors, only education, tenure, and gender are significant at 0.001 here, at 0.001. Intercept, the intercept is significant also, but whether that's significant or not, we still include that in the model. Now, experience is significant only at only at 10% class. That na to, no, here. And if we're going to be very strict with the 0.05 level of significance, then we conclude that this is not significant. Okay, race is not significant, civil status is not significant, and number of dependents is not significant. Okay, so let's interpret this first. So what does this estimate mean? 0.57, which is highly significant. Okay, just like how we interpreted this a while ago, for every 1 year increase in education, why 1 year? Because education is in years. You have to follow the dimension of your data. Education is in years. Okay, so for every 1 year of education, for every 1 year increase in education, there's a corresponding 0.57, around 57, okay, $0.57 increase in hourly wage, comma, ceteris paribus. So now, ceteris paribus has an important meaning. Okay, because we were saying here that if we increase education by 1 year and let the others remain the same, okay, the others should remain constant, you're not changing it, only education is, then there will be a $0.57 increase in hourly wage, again, ceteris paribus. Ceteris paribus means all things being the same. In what context is that? We say that this 0.57 is the increase in hourly wage if we increase education by 1 year. But the others should not have any increase. Okay, they remain constant. Okay, how about experience class? Assuming that this is significant, okay, assuming this is 1 star or 2 stars or 3 stars, then for every 1 year increase in experience, there's a corresponding $0.02 increase in hourly wage. Ceteris paribus. So all of this class are the effect, okay, the effect of a 1 unit increase in your independent variable on the the effect on the dependent variable hourly wage. Okay, so let's take a look at this one here. Let's start with the quantitative variables. Number of dependents, 0.14. Okay, unfortunately, this is not significant. Okay, so this will not enter the picture of your model. Okay, however, assuming it's significant, then how do we interpret this? For every for every increase of 1 dependent, okay, there is a corresponding $0.146 increase in hourly wage on the average, ceteris paribus. Okay, so if that was significant, you interpret this as in terms of the units of the variable. In that case, dependence for every for an increase of 1 dependent, okay, there's a corresponding $0.146 increase in hourly wage, okay, ceteris paribus. All right. So we have interpreted the quantitative variables. Now, how do we here tenure? I forgot. What's tenure class? Tenure is also in years, and it's highly significant. So for every 1 year increase in tenure, on the average, there's a corresponding 0.13 or 0.14 rounded off, $0.14 increase in hourly wage, ceteris paribus. Okay, so tenure is also highly significant at 0.001 here, 3 stars. Okay, now let's go here. Race, gender, civil status. Now, why do you think a level of race here was included? Bakit kaya, no? Ba't kaya nag-race white yan? Okay, in order to understand that better, let me once again do the table. Okay, table, wage, dollar, race. Okay, if we recall class, you have 2 levels in your race variable. You have non-white and white. Okay, what appears here, what will happen is that for race, okay, what will happen is that there will be a dummy variable introduced. Okay, so let me write that dummy variable. Dummy variable. Okay, what's a dummy variable class? A dummy variable, okay, is a value we assign to your factors or your character variables so that they can form part of the regression model. Because if you see here, race is white and non-white, right? So this is character variable. How can that enter into the equation? Okay, so the reason why we converted it into a factor, okay, but in R now, even if it's not converted into a factor, it will still run. But my point is here, you have two levels of race, non-white and white. What will happen is that R will assign a dummy variable will be assigned. What will be the dummy variable? It will be, let me call it levels, sige, M minus 1 na lang. M minus 1. Okay, what's M class? M is the number of levels. So there are two levels here, okay? And then what will happen is that R will assign M minus 1 dummy variable. It's going to replace race with another variable which we call the dummy variable. So how many dummy variables will be introduced? How many levels do we have? Non-white and white. So that's 2 minus 1. So R will introduce here a race dummy variable. I'll just call it dv. Okay. So for R, what will happen is that the level that appears first alphabetically, note alphabetically, no? It's not how it appears here in your data. It should be alphabetically. This one, non-white class, since it appears first alphabetically before white, this will be your benchmark or reference. Benchmark or your reference. So what does that mean? It will be your benchmark or your reference, and it will be assigned a value equal to 0. Okay? The benchmark is the level that appears first alphabetically, so it's non-white. So it will be assigned a value of 0. The white now will be assigned a value of 1. Okay? So this is the dummy variable that will be introduced, and it will only be one dummy variable. Why? Because you have only two levels, minus 1, so you have one dummy variable. So this will be replaced by white will become, okay, 1. Okay? White will become 1. So all the whites here, class, will be replaced by 1 here. And your non-white, which is your benchmark, will be replaced by 0. Non-white, 0. So this is what will happen, class. Your race variable, which is a factor, character, will be replaced by a dummy variable. And we're going to replace either 0 or 1. It depends on the level, okay? It depends on the level, but it will always be 0 or 1. Okay, so this is your race dummy variable. What about your gender? So this is now your gender dummy variable. Once again, it will be converted into a dummy variable. And then there are two levels here, female and male. Okay, female and male. So how many dummy variables will be introduced? Count the number of levels, 2 minus 1. So therefore, only one dummy variable, only one column here. Okay, and then which will be the benchmark? The female will be first alphabetically compared to male. Therefore, this will be the benchmark. It will be given a value of 0. And then your male will be given a value of 1 in your dummy variable. So this one, female, this will be 0. Okay, female 0, male 1, etc. Okay, so R will automatically replace these factors with these dummy variables. And third, we have your civil status. So you have single and married. Okay, this SM, this appears first. Therefore, this is your benchmark. This will be your benchmark variable. It will get a value of 0. This will get a value of 1. Okay, and how many dummy variables are we getting? Only 1, because there are two levels. Minus 1, so only 1. So once again, you create another dummy variable here, civil status, for example. And then your single will be 1, married will be 0. Okay, etc. So that's what will happen. Now, okay, just to, what if you have, just to illustrate this class, suppose you have 3 levels. Okay, let's make it simple. Let's say you have another variable here. So let me just write the variable here, class. Okay, let me delete this first. So I'll have another variable here. Let's call it, let's say year level, year level. And let's say the this just consists of, let's say 4 class. Frosh, example only, sophomore, senior, junior. Okay, let's just do 4. Senior, Frosh, sophomore, etc. Okay. Now the question is, this is Frosh. This is Frosh also. How many levels do you have? Frosh, sophomore, junior, and then senior. Okay, so you have 4 levels. Therefore, how many dummy variables are we going to introduce? Kindly chat, please, in the chat box. How many dummy variables are we going to introduce? How many? 1. Okay. Okay, try again, Dom. What's the formula for the number of dummy variables? It's the number of levels, m, minus 1. So how many levels do we have for this variable, this year level? Frost, sophomore, junior, senior. So there are 4 levels here. Therefore, we will introduce 3 dummy variables. Okay. All right. Yeah. 3. No. Thank you, Angel. Thank you. Okay. Thank you, Dom. Yeah, you're correct. 3 dummy variables. No? So, paano gagawin yun? How do you now introduce 3 dummy variables? Okay, I'll erase this. Okay. Take note, class, that what appears here alphabetically first is Froshman. So Frosh will now be your dummy variable. It will be given a value of 0. Okay. So you have here 3 dummy variables. You have a dummy variable for sophomore, for junior, and then senior. Okay. So this is what will happen. So this is Frosh, and Frosh is the benchmark variable. It's not sophomore, it's not junior, it's not senior. Okay. So Frosh here will be represented by 0, 0, 0. So take note of that. Okay. And that's why we can introduce 4, we can just introduce 3 dummy variables, and still all your levels are accounted for. Okay, for this one, Frosh again, so 0, 0, 0. This is sophomore, so this should be 1, 0, 0. Senior is 0, 0, 1. Junior is 0, 1, 0. Senior 0, 0, 1. Frosh 0, 0, 0. Sophomore 1, 0, 0. Okay, so all the levels will be accounted for, class, by introducing 3 dummy variables. Okay, you don't need to introduce here. Maybe you'll be thinking, maybe you can introduce another one, Frosh. So this one will be now 0, 0, 0, 1. Okay, Frosh is also 0, 0, 0, 1. Okay, now you don't do this because this will lead to what we call a dummy variable trap. Okay, and it will lead to what we call multicollinearity, which is a problem. Okay, so we don't introduce 4 levels. This will result into a dummy variable trap. We will have a problem with the model if we do that. So you only introduce m minus 1 dummy variables. And how does R do that? Get what appears first alphabetically, assign it 0. Okay. and create the other dummy variables. Okay, let me pause for a while, class, and see if you're able to so far understand my explanation. I'm sorry I had to lay this down. Okay, I'm sorry I have to explain this so that we understand the regression output. Okay, kindly please chat if this concept of creating dummy variables is clear, and it's only done for factors class. Okay, for factors. Of course, not for the others education because they're quantitative variables. Okay. All right, Angel, thank you. How about the others, please? Comment, please, class. Okay, good. Thank you. All right, let's now go back to our, let me delete this. So now you know what's happening, class. Now you know why these factors can be part of your regression output because they're converted into dummy variables, which are values of usually 0 or 1. Okay, so let's go here. We have this. What's the meaning of this? Although it's not significant, but let's assume it's significant. Okay, you notice now that race is now attached with the, okay, with white. Why is this so? Remember, non-white is your benchmark variable, and it's given a value of 0. So what will appear here is race white, and it's 0.11 approximately, and it's not significant, but let's say it's significant. So how do we interpret this? Remember, these are categorical variables, these are factors, and this should be interpreted in relation to the benchmark variable. Okay, so how do we interpret this 0.11? So on the average, white employees receive $0.11 more. Why more? Why more? Class, because this is positive. Positive 0.11. So you're interpreting white in relation to your non-white. Okay? So on the average, white employees receive $0.11 more than their non-white counterparts, ceteris paribus. We're assuming that this is significant. Okay. How about this? Gender male. Again, the same thing. And it's statistically significant plus. It's statistically significant at 0.001, highly significant. So what does this mean, class? On the average, male employees receive $1.76 more than their female counterparts, ceteris paribus. Okay? And this is significant. So maybe the question is there discrimination? Why is it that male employees receive on the average $1.76 more than their female counterparts? Okay, that's a good question to ask. And thirdly, we have this civil status, again, single. So this will be interpreted in relation to the married benchmark. On the average, and this is negative class. This is negative. On the average, single employees receive $0.46 less than their married counterparts, ceteris paribus. Okay. All right. So let me repeat once more. On the average, white employees receive $0.11 more than their female counterparts, ceteris paribus. Assuming again it's significant. On the average, male employees receive $1.76 more than their female counterparts, male, female, okay, ceteris paribus. On the average, single employees receive $0.46 less than their married counterparts, ceteris paribus. Okay, again, sorry to keep on asking if you got that, class, because these are very important, because in your project, for example, you'll have to explain that. You'll have to explain what this means. Especially, usually in regression outputs, you have you have categorical variables, you have factors used in explaining your dependent variable. Okay. Feedback, please, class. Yeah, very good question, Angel. Okay. Is it possible to change the variable? For example, for race, change, let's say, non-white instead of, yes, that's possible. We'll discuss that next meeting, okay? We're going to use the function relevel, okay? Change the level, okay? Because, as Angel asked, what if I want the benchmark to be white? Because here the benchmark is non-white. Is that possible? Yes, that's possible. Okay, and what will happen is that magre-reverse lang yung yung sign nito. Okay, so let's suppose we did that. So ang mangyayari dito, magiging ang lalabas dito race non-white. Why? Because we assigned the white level to be the reference variable. Okay, so pwede, madali lang yun, no? But we'll discuss that kasi gusto ko matapos pa yung ibang regression natin. But thank you, Angel. That's a very good question. That can be done. Will the estimate change? Yes. Magpapalit lang ng sign. Okay, for example, this will become gender female now. Okay? So ang gagawin natin, sabi natin, gusto natin si male is equal to 0. Okay? Kasi now si female is equal to 0 kasi siya yung alphabetically first, no? And then female now will become 1. So yung mga 1 dito, class, yung mga 1, siya mag-a-appear dito. So magiging gender female to. And the result will be negative 1.76. And how do you interpret that? On the average, female employees receive $1.76 less than their male counterparts, ceteris paribus. Okay, ganun lang, no? But yes, you can change the level. And we're going to use the function relevel. Madali lang siya. Okay. Angel, did that answer your question? Okay, good. Thank you. How about the others, class? So far, okay na ba tayo dito? Okay, so that we can move on. I want to be sure that everyone understands so far. That's why I keep on asking questions, class. Waiting for your comments, please. Okay, thank you, Hannah. Okay, Dom, thank you. Okay. I'm missing the Dom, again, Nico, Nick 4. Okay, I'm missing some. Okay, Jet, thank you. All right. Si Michael, kamusta? Parang, si Michael yan. Thank you. Okay, good. All right. So, I hope you understood this, class. Yung mga quantitative variables, they're straightforward to interpret. No? Okay. So, what will now appear in your equation? Okay. So, I'll just recite the equation, class. Hourly wage is equal to negative 3.39. Okay, I'm just rounding it off, class. Plus, okay, plus what? 0.57 times education. This is included because it's statistically significant. Experience will not be included in the equation. Okay. Tenure will be included. It's statistically significant. So it will be 0.138 times tenure. Okay. Race will not be included. It's not significant. Gender will be included. Okay. So plus 1.76 times gender. Okay, this will not be included, and this will not be included. So plus your residual, plus epsilon sub I. So only include those that are statistically significant. Okay, and plus of course the intercept, whether whether it's significant or not. Okay, so far we have we have interpreted each of this. Now what's the meaning of this intercept? We said that it's the value of your hourly wage, negative 3.39. Okay. But again, I said that we don't put practical significance on the intercept because this is impossible. Okay. You don't have a wage of negative 3.39. So anyway, this is class the average hourly wage of a person, okay, of an employee with where all your predictors are all equal to 0. So negative 3.39 is the average wage of a person with no education, no experience, no tenure, no number of dependents, who is what? Non-white, who is female, and who is married. Okay, take note. Let me repeat, class. The intercept stands for the average wage, hourly wage of an individual with zero predictors. So wala siyang education, zero experience, zero tenure, zero number of dependents. Take a look at this class. Si race white class, di ba ang pag zero to, si female yun. Si non-white pala. Okay, right? I hope you recall that. So who is non-white, who is female, and who is married? So yun ang ibig sabihin class ng negative 3.38 na yan. Okay, what will happen if, on the other hand, the person is male? So kung male yung person class, yung average, no? Okay, 0 years of education, 0 years of experience, 0 years of tenure, walang number of dependents, pero male siya. Pag male siya class, madadagdag to. So that will be around 3.4, negative 3.4 at saka plus 1.7, sabihin na natin. So that will be negative 1.7. That's the average age of a person with no education, no experience, no tenure, no number of dependents, who is non-white and female, and male, no? Male and married. Okay, lalabas dito. Kasi male, 1.7 siya. Okay, madadagdag dito. So naging negative 1.7. Okay, so those are things that that can be asked. Plus kasi may isang quiz tayo no na multiple choice. Okay? So yung mga diniscuss natin lalabas doon as multiple choice. Okay, any questions about that class? All right, no questions. Sige, let me move on class. Now take a look at this. So which is the better model class? Yung una natin, asa ba yung una natin? Sorry. Okay, i-reproduce ko lang siya dito class ha. Let me reproduce that here so that we have ito na pala, no? Ito pala. Ay, wait, asan na yan? Okay. Here. Okay. No. Model 1 class. Okay, let me rewrite here. Control Alt I. Mod 1, no? Mod 1 is just sorry. Mod 1. Summary Mod 1 na lang para lumabas na. Summary Mod 1. Okay, this was the first yung education lang yung ginamit natin, di ba? Hourly wage regression education. Notice class that okay, I'm sorry. Ito muna, nakalimutan ko explain to. Okay, all of this class have their own, take note, no? All of this have their own hypothesis test. This is H sub O. This is your beta, your intercept, no? Beta 0 is equal to 0. This is H sub O, beta 1 is equal to 0. Okay. For this one, we reject this hypothesis. For this one, this is beta 7, okay, is equal to 0. So we fail to reject the null hypothesis that beta 7 is equal to 0. Okay. Now, for this one class, why 518 degrees of freedom? If you recall, class, the degree of freedom here, for all these individual, this is what you call your individual t-test, no? T-statistic ang ginagamit natin dito. It's equal to n minus k minus 1, no? N is 526 observations. K is how many predictors? 1, 2, 3, 4, 5, 6, 7 predictors. So 526 minus 7 minus 1 because we lose 1 degree of freedom when we compute for the intercept also. So that's 518. Doon ang galing tong 518 na to. Okay, and then dito dalawa ulit sa F-stat. This is for your ANOVA. Okay, this is degree of freedom 1, which is the number of predictors, 7. This is degree of freedom 2, n minus k minus 1. P-value is this one. Now, the statistics here, kanina hindi natin ginawa yung statistics nito kasi iisa lang naman yung predictor natin dito eh. Okay, so this is the joint test class. The null hypothesis is that beta 1 is equal to beta 2 is equal to beta 3 is equal to dot 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 beta 7, number of dependence yan, is equal to 0. Okay. So lahat daw ng predictors natin is equal to 0. This is also called the goodness of fit test. And the p-value is practically 0. So we reject this null hypothesis that all your predictors are all equal to 0. At least one of this is significant, and we were able to show it here. May mga significant predictors tayo. Hindi lahat sa kanila 0. And which is the better model class, the full model or model 1? The full model or model 1? If we base it on the adjusted R squared, then mas maganda si full model. Okay, bakit? Si full model class, let's say this is your hourly wage. Sabi natin kay model number 1, only around 16% lang, di ba? 16% lang ng variation ni hourly wage ang kayang i-explain ni model 1. On the other hand, si full model, mas malaki yung percentage ng variation ni hourly wage ang kayang i-explain niya kasi 36.19%. Okay, 36.19% is higher than the 16%. Okay, again, let me pause again. If clear sa atin yung mga pinapaliwanag ko, I hope it's clear, class. Okay, we're looking at the anatomy of our regression output. Okay, thank you, Angel. Comment from the others also. Okay, good. Okay, good. All right. Okay, so now, sorry, we said that the adjusted R squared is one of the parameters used in order to assess our model. Here, 36.19%, which means that 36.19% of the variability of our dependent variable hourly wage can be explained by our model. If we only used education, we only got 16%. So that's fair enough because we have several predictors. For education, you only have one. But there's a statistical test class. There's a statistical test in order for us to determine, okay, Control Alt I, to determine if our model class is, okay, if our model is in comparing the two class, the full model and then the model 1, which is the reduced model using only education. So we use a function called ANOVA. Okay, but let me explain first what this tests. Okay, so when we use ANOVA class, we're testing the null hypothesis that that you have two models here. You have model 1 and the full model. What's the difference between the two class? Model 1 has only one predictor, education. Full model has the 7, all the predictors. So the null hypothesis for the ANOVA will test whether, okay, this is called your restricted model, R, restricted, ito, unrestricted. Bakit restricted to? Mas konti yung predictors natin, isa lang. Ito unrestricted, mas marami. So ang tinetest natin dito, class, kung yung mga dinagdag natin dito sa unrestricted, ano-ano siya? What are they? So, experience, beta 2. Sino pa? Tenure, beta 3. Sino pa? Race, beta 4. Sino pa? Gender, beta 5. Sino pa? Number of dependents, beta 6 is equal to 0. Okay. So we're testing kung useless ba any one of this to be included in your model. Okay? Baka pwede ng education lang. Why is it so, class? Kasi kung kaya naman natin i-model si hourly wage just using one predictor, edi okay, di ba? Why make it more complex when in fact just using one predictor will be sufficient? And that goes also to class 4, let's say comparing 4 predictors versus 3 predictors. The one with 3 predictors will be your restricted. The one with 4 predictors will be your unrestricted. Tapos itetest natin yung null hypothesis natin dun. Kung yung dinagdag natin sa unrestricted, we're going to test if it's equal to 0. Kasi ang tinetest natin, does it make sense to add more variables to your model? Okay? So in this case, ang null hypothesis natin, does it make sense to add beta 2? Kasi ito beta 1 to education. So beta 2 is experience, tenure, race, gender, civil status, and the number of dependents. Does it make sense to include them in your model? May beta 7 pa pala dito. Okay, so that's what we're going to test. Okay, let's do that now. So we do ANOVA, analysis of variance. And the two that we're going to compare is mod 1, di ba? And your full model. Yan. Tinetest natin kung mas okay ba si, in other words, ang null hypothesis natin, restricted model is better. Okay, or in other words, lahat ng mga betas na dinagdag natin sa full model, equal to 0 naman yun eh. Wala naman significant dun. Okay, so if I run this class, what do we have? Model 1. Yung simple lang. Model 2. Itong mas kompleto. Okay, so ang tinetest natin dito is experience is equal to tenure, is equal to race, is equal to 0. All of them are all equal to 0. And then the p-value class is highly significant, which means we reject the null hypothesis that all of these added variables are all equal to 0. Okay, or in other words, we reject the null hypothesis that the restricted model is better. Okay, mas maganda yung nagdagdag tayo ng predictors class. Okay, by the p-value here, highly significant. Okay, so which is better, model 1 or model 2? Model 1 or the full model? The full model is better class. So if we're going to choose among the two, is it the model 1 lang, isang predictor, or full model lahat? Okay, the answer there is, based on the ANOVA analysis of variance, okay, we prefer the full model because we're rejecting the null hypothesis that the extra variables are all equal to 0, or that the restricted model is preferred. All right, stop again, class. Stop again. That's another test. Okay, you notice that here we're having quite several tests. Okay, and may I again have your feedback, class, if so far this is clear. If it was significant, the conclusion drawn po is that it's better than the than better that the variance on hourly wage is only explained by, okay, significant or, okay, wasn't significant. Yes, that's correct. Ang tanong ni Dom, what if this was, let's say, 0.0, 0.10 or 0.2? So 0.2 siya. Anong conclusion natin? Since this is 0.2, therefore, we reject the null hypothesis that your your restricted model is, sorry, we fail to reject, no? 0.2 kasi 0.2. So, ang p-value natin 0.2. So, non-rejection yun. We fail to reject the null hypothesis that your restricted model, we fail to reject that it is better. Hindi natin mare-reject yun. Or, ang sinasabi din natin nun is that these are all equal to 0. Yung mga yan. No point in including them in your model because anyway, their values are all equal to 0. So that's, you're correct. Ang sabi ni Dom, no? Ang conclusion natin is it's better that the variance is only explained by education. That's true. Thank you, Dom. That's very true. Tama yun, no? Okay. So any other questions? And again, may I request you to please chat in the chat box, class, kung naintindihan natin tong ANOVA na to. Okay, before we go on to the next step. Kasi dito napakita natin, we're going to use the full model. Kasi mas maganda siya kaysa dun sa simple regression model lang natin. Okay, waiting for your feedback, class, if you're getting it. Okay, thank you. Angel, thank you. Let's wait for the others. Again, class, feel free to, I did not know previously that ANOVA, yeah, pwede, pwede, Dom. So, si Nicolo following, Mike following, okay. All right. No questions? Okay, good. Okay, so let's review this. Let's review our full model. So I said a while ago that the equation should be, okay, our equation should be, let me write it. Okay. Hourly wage is equal to -3. Let me just drop it to 2 decimal places, 39 plus, okay, 0.57 times education, which is significant siya. And then plus 0.14 times tenure, significant, plus 1.76 times gender, significant, plus your epsilon, plus your residual. So we only have class 3 predictors. Kasi tatlo lang yung significant. Okay. So is that the final model, class? The answer is no. We can do what we call a stepwise regression. Stepwise. So I'll explain what stepwise is. Dalawang klase siya. Tatlo actually. Forward, backward, forward, backward, or both. So combination ng forward at saka backward. Okay, we're going to illustrate here backward integration, backward stepwise regression, because this is a lot easier to perform compared to forward or both. Okay, so ano yung backward class? Sa backward class, you start with the full model. So lahat pinasok natin ng predictors. And then, once you get your model, you see that there are 1, 2, 3, 4 non-significant predictors. Okay, so we don't conclude that we only have 3 predictors. What we're going to do is do stepwise backward regression by eliminating the non-significant variables one at a time. So mag-i-elimination tayo. Okay, so dito anong tatanggalin natin, class? What you do is you focus on the t-value, class. Okay, and the non-significant ones will have the lowest t-value. Okay, in absolute sense, no? Ibig sabihin, hindi natin papansinin yung negative or positive. Absolute sense. So these are your insignificant predictors. Number of dependents, civil status, okay? Si race, at saka si experience. If you notice, these significant predictors have very high t-values. Okay? 6.59, 11.034. So hindi sila pwedeng maging living variable. Living class yung aalis, no? Live. They cannot become your living variable. The living variable is the variable that has the least absolute t stat absolute value. So may I ask you please to chat here in the chat box, sino yung magiging living variable natin among those predictors? And as I said, no way for them to come from the significant predictors kasi matataas yung t-values yun relatively. So which among our variables will be the living variable? Lean, Leaving. Kindly chat, please. Come on, class, come on. Okay, raise. Dom, raise. How about the others? What's your guess, class? What's your guess? Dom, guess is raised. How about the others, please? What's the parameter, class? What's the basis? We will choose among your predictors and choose the least t-value, absolute value. So you don't count the disregard the negative signs. So ano ba yung pinakamaliit, class? T-value. Waiting for your chat, class, please. I hope we can respond faster so that we can cover more materials. I noticed kasi medyo naglalag tayo, no? But it's okay, class, if you're taking down notes. That's understood. But like this question, okay, it's actually it's pretty straightforward. So how about the others, class? We need to determine the living variable. Ano yung paalis na variable? What will that variable be? Hello, class. Hello. Hello, class. Can you hear me? Living variable. I'm not getting any response, class. Okay. Okay. Ang sabi natin, class, t-value, di ba? T-stat. Ano ba yung pinakamaliit dito, class? Ito, 2.257, no, di ba? The others are 1.5, may 6. Sabi ko nga, di ba, class, yung mga significant, matataas ang t-value niyan. Education here. 11. So they cannot possibly be the living variable. Highly significant sila eh. Yung mapagpipilian natin, class, ng living, yung aalisin natin sa model natin, are those with low t-values. Okay, sino ba yung mga insignificant dito? Ito, 1.5, 1.3, 0.2. So si race, class, si race. Okay? I think pretty straightforward naman yung question ko. Race will be your living variable, class. Okay? Anong living? Aalisin natin siya. Okay? All right. Based on the t-values, t-values. Okay. So let's now create another model, class. Let me clear the drawings. Okay. And then here. Okay, I'm going to create, okay, Control Alt I, and then I'll copy this one, yung full model natin, palitan na lang natin ng formula. Here. Control C. Control V. Let's call this model 2 class. Mod 2. So mod 2 tayo, no? Mod 2. And then, education, experience, tenure, tanggal si race. There. Delete. There. Tanggal si race. So, 1, 2, 3, 4, 5, 6 na lang. 6 na lang yung magiging ano natin. Okay, 1 to sa second line. Okay, para mas makita. Education, experience, tenure, gender, civil status, number of dependents. Okay, and then summary, mod 2. Alright? So, lagyan natin dito. Yung notes class, leaving stepwise regression, backward. Kasi backward tayo, kasi nagsimula tayo sa full model. So, pabalik tayo. Stepwise regression. Leaving variable is your race, no? Oops. Ano nangyari doon? Leaving variable race. Okay. Tanggal si race class. There. Okay? So let's summarize this. Let's run this class. Control Enter. All right. Sorry class, it's sorry hindi tayo nakapag-break 8:25. Is it okay for us just to continue up to 9 o'clock, no? Tapos para hindi na tayo mag-break. Kaya niyo ba class? Para mas mas tuloy-tuloy yung natin kasi masisira yung momentum natin class pag mag-break pa tayo. Is it fine with the class, please? May I have your approval? Kung okay lang na Okay, thank you. Okay, thank you. And then we call it at 9, at the latest siguro 9:05, no? Kung sakaling hindi tayo matapos. All right, so we now have our model number 2. Ang model natin, wala na si race dito, di ba? Okay? And data is equal to wage. All right? Now let me start here from the bottom. Okay. 3631 yung adjusted R squared niya. Yung isa kanina 3619. Di ba? All right, so I can now explain this. All right, itong multiple R squared class, 37.04. Multiple R squared class, kinocompute din niya yung capability ng model to explain the variance of your dependent variable. However, it will keep on increasing by adding more variables. So dito, 7 yung predictors natin class, 37.04. Dito, we have 6 predictors only. Multiple R squared natin, 37.03. And that's expected kasi mas marami yung 7 predictors. Kaya that's why class, we don't use this to compare. We use rather the adjusted R squared. Kasi syempre, lagi mas mataas yung multiple R squared ng mas maraming predictor. Okay? Yung adjusted R squared, it's computed by penalizing the model for adding more variables. So ito mas fair itong this measure, no? 3631, yung isa 3619. So you can see that based on adjusted R squared, mas maganda si model 2 kaysa kay full model. Even if the multiple R squared of the full model, as expected, is higher. That's why, again, we don't use the multiple R squared as a basis for comparing models. Mas maganda tong adjusted R squared ni model number 2. And then take note class, what happened here? Still significant si education, still significant si tenure, still significant si gender male, okay? Still si experience hindi significant at 0.10 lang, okay? And then civil status and number of dependents is also not significant. Okay, however, tumaas yung adjusted R squared natin. Okay? All right. So, what next class? Again, okay, this is not yet the final model. No? Kasi may mga insignificant predictors pa tayo. So again, we will determine what will be the leaving variable. Again, look at the t-value. And again, class, I hope you can now Answer in the chat box. What will be your living variable, class, please? Paki ano nga, class, sa chat box. What will be our living? Yung aalisin natin na variable. Okay. Thank you, Jet. How about the others? Yeah, good. Yeah, good. So happy, class, you got it. Tama, no? Tanggalin natin to si number of dependents. This will be your living variable. Okay, so let's do that. Copy na lang natin to, class, ito. Okay. Control C. Copy natin. Mag-i-adjust na lang natin to. Control V. And let me call this model 3. Control X. Model 3 na lang to. Control V. Ah, wait. Sorry. Okay. May nakalimutan ako, class. Control V. Okay. Here. So, this is our model number 2. Walang race, no? Full model natin, ito, with race. So, although tumaas yung adjusted R squared ni model number 2, we will have to test this statistically, no? Okay. Mag-a-ANOVA ulit tayo. Okay? So, this time, compare natin, Control V. We're going to compare mod number 2 and full model. Sino yung natin dito, class? Sino yung unrestricted? Sino yung restricted natin? Si model 2, class, walang race to, di ba? So this will be your restricted. Full model will be your unrestricted. Okay? So take note of that. Si restricted model, class, you must counting variables. Or in other words, class, ang null hypothesis natin dito is, technically, it's beta, ano ba yung race? Pang 4, no? Or beta ni race is equal to 0. So, ang sinasabi natin dito, does it make sense to add race? Okay? All right? So, that's our null hypothesis, no? Or in other words, your restricted model is better. Bakit? Yung restricted model natin, class, walang race eh. Si full model, may race to. Plus race to, di ba? So, sino mas maganda? Yung may race o walang race? Depende. Kasi kung 0 naman yung beta natin na to for race, then why include it, di ba? Bakit nyo isasama sa full model when your beta for race is equal to 0? So that's what we're testing here. Okay, i-run na natin, class. Run na. Take note of the hypothesis, no? Model number 2 is the preferred model kasi siya yung restricted. Run. Naglolo ko tong code chunk ko na to. Dito na lang. Control Enter. Okay. All right. So model number 1 natin, walang kasamang race. Full model natin, di ba? Full model may kasamang race. So the null hypothesis is, sulat natin dito para mas clear sa atin. Null hypothesis, okay? Restricted, which is mod 2 is better. Bakit kasi? Ang tinetest natin dito din, class, is that yung beta, okay, B ni race is equal to 0. Okay. B underscore. All right. The p-value is 0.7971. So this is definitely much larger than 0.005. So, at anong conclusion natin? We failed to reject the null hypothesis that the restricted model is better. So in this case, model number 2 is better. No? Mas maganda sin model number 2. Mas maganda yung walang race. Okay, so kasi it turns out that the beta, the estimate for race is equal to 0. All right. Again, let me pause for a while and ask you if clear yung ANOVA natin, please. So kino-compare natin class yung original model natin at saka yung binawasan natin. Yung original model natin, yung full model, binawasan natin siya ng race. Tingnan natin kung is it really correct to remove the race variable. Waiting for your feedback, class. Thank you, Dom. Okay, thank you, Nick. Okay, Jet, thank you. Anna, thank you. Michael, thank you. Okay. Okay, I hope, sino pong wala? Si Angel? Angel, are you able to follow? Okay, good. All right. Thank you. Okay, so going back here, class, di ba? May living variable na naman tayo. Yung living variable natin is numDep. NumDep na. Sabi nyo kanina, di ba? So ito, matatanggal natin si numDep here. Remove. No more numDep here. Okay? So, hourly wage, regression, education, experience, tenure, gender, and civil status. Lilima na lang. And then this should be model number 3. And when we run this class, okay, ano nangyari? Okay. See, education, still significant. Tenure, significant. Gender, significant. Tatlo pa rin, no? Tatlo pa rin yung significant natin. Pero, meron tayong dalawa na natitira, no? Na hindi significant. So, what will be our living variable here, class? Dito sa model natin. Kung tatanggal ulit tayo, no? What will be our living variable? It will be the lowest t-value, which is, it should be experience. Tama ba, class? Is it experience? T-value 1.55. T-value nito 1.96. So, tama. Experience nga. Okay. Thank you. You're correct. It's experience, class. Alright. So, kopyahin ulit natin yung model natin sa taas. So, iterative lang to, class, no? So, let's start from here. Okay. Control C. And then, okay. May kulang pa ba tayo? Yeah. Okay. Anyway. Lagay ko muna dito, ano? Control V. Nakopya ko ba? Hindi. Okay. Anyway. So, we forgot one thing, no? Diba? Pagkatapos natin mag-create ng model number 3, you have to compare that with the previous model. Okay, so I'll copy this. We're now comparing model number 3 and model number 2. Okay. Kasi baka, and also, class, take note, the adjusted R squared went down a bit, no? Kanina 36.31 eh. Ngayon naging 36.21. Okay? But it's not really the main basis. Control. Okay. So, this time, we're comparing model number 2 and model number 3. Model number 3. And in this case, ang restricted natin si model number 3. Diba? Kasi si model number 3, tinanggal natin ng, ano yung tinanggal natin doon? Number of dependents, no? So, this is B raised numDep is equal to 0. Okay? Sorry, I have to put this in, okay, quotes. Comment pala. Okay, so let's run this class. Model number 2 versus model number 3. Model number 3 is the restricted model. Wala siyang number of dependents. So let's run this. And you can see also that the p-value is 0.18. So we failed to reject the null hypothesis that model number 3 is better. Si model number 3, huwag kayong ma-confuse dito, class, ha? Ang model number 3 natin yung walang number of dependents there. Okay? So we failed to reject the null hypothesis that model number 3, which is this one, in this table, it's model number 2 here. This is better, okay, kasi the beta for number of dependents is equal to 0. Okay? So wala siyang gamit sa model. P-value 0.184. Okay? So because model number 2 is better. Kung model number 1 is better, class, then stop na tayo kasi okay, hindi pwedeng tanggalin class yung isang variable eh. Ganun yung significance nun. Okay, but we'll explain that as we tuloy muna natin to, no? So this is a model number 3 na to, no? And sino tatanggalin natin? Experience. So, once again, I'm going to copy this. Copy ko na lang to create the next model, model number 4, Control C. And then I go here, Control V. I'll call this model Control X, model number 4, Control V, Control V. And then I'm going to delete experience. There. So, apat na lang class. No? Education, tenure, gender, civil status. Okay, let's run this. Okay, take a look, class. What happened? What happened here, class? It turned out that civil status became significant. Okay. Now, had we not done this, class, kung yung unang-una pa lang na model natin, di ba, yung full model natin, saan yan? Where's our full model? Here, class. Kung dito pa lang, class, ang pinili, what we chose are only the significant ones, the 3, and then deleted everything here, then hindi masasama si civil status. In this case, kasama si civil status eh. Significant siya, 1 star, that's significant at 0.05. Right? And then the adjusted R squared, of course, we expect it to go down, but it's 36%. Okay? And then let's test. Check natin, class. Ano ba ulit tayo? Kasi every time we generate a model, class, Control C, using stepwise, kailangan i-check natin Control V. This time, model 4. This is number experience to, no? Experience yung tinanggal natin. Okay? So we're comparing model 3 and model 4. Delete. Okay, let's test, class, if indeed, okay, model number 4 is better than model number 3. So we're testing whether yung tinanggal natin na experience, okay, is really 0. Run. All right. 0.1198. Okay, therefore, we fail to reject the null hypothesis that the restricted model number 4, the one with no experience, is better than model number 3. Okay, so our model equation will be, okay, tanggalin ko lang to, class, ha? Ano ko na lang, no? All right. So, kunin ko yung names names ni model number 4. There. Ito names natin, no? So we can get the coefficients, names, dollar, names, okay, sorry, mod pala. Mod 4, dollar, okay, coefficients. Control Enter. Okay. Ito yung coefficients natin, di ba? Therefore, pag isusulat natin model natin, class, hourly wage is equal to, sulat ko na lang dito, no? This is our intercept. Copying ko na lang to. Control C, Control V. Okay. Plus, okay, this one, Control C, Control V, times our education. Times education. Control C, Control V. And then plus, tenure naman, Control C, Control V, times tenure, okay, plus Control C, Control V, times Control Z, times gender lang, class. Ang variable natin gender, hindi si gender male, no? Gender, okay, plus this one, Control C, Control V, times civ status lang. Qualifier lang yung single dyan, Control C, just to help us interpret. Control V. Okay, so copyhin ko lang to dito, Control C, dito ko ilalagay sa ano. Here. Ilalim. Okay, so this is our model class. Of course, meron tayong plus E. Isabay. Hourly wage is equal to, this is your intercept, plus this is your, okay, parameter or coefficient or the slope of education, plus 0.15 times tenure, plus this one times gender, and then plus this one times civil status. Okay, and then plus your residual. Okay, so let me Control C if you want to copy this, but I hope you're able to, I hope you know how to already get the values, no? Okay, so quickly let's interpret this class. So this education, 0.53, we say that for every 1 year increase in education, there's a corresponding $0.53 increase in hourly wage, okay, ceteris paribus. For every 1 year increase in tenure, there's a corresponding $0.15 increase in hourly wage, okay, ceteris paribus. For, on the average, male employees receive $1.71 more than their female counterparts. Okay. On the average, single people receive $0.69 less than their married counterparts. What's the meaning of the intercept here? Negative 2.16. That's the negative 2.16, which is the intercept, is the average hourly wage of a person who has 0 years of education, 0 years of tenure, who is female, who is married, who has 0 years also of the others, no? Experience, 0 years of number of dependents, etc. All zeros, class. Okay. All right, let me pause for a while. Maybe you're jotting down notes. Once you're done, class, okay, once again, I'll request you to give feedback if so far up to this point, our final model consisting of education, tenure, the gender and civil status, if we're clear about that. Is a stepwise regression process the solution for in addressing multicollinearity? Since the last meeting, we noticed that experience and tenure. All right. Okay. Thank you, Dom, for that question. The answer to this question is, ang sinasabi natin kung solution siya for multicollinearity, not yet, no? Not yet. Because we will have, after this, you'll have to do diagnostics. We will have to do diagnostics. So for example, in order to determine kung may multicollinearity, tingnan natin, no? Dito. Let's put here, Control Alt I, VIF. Let's see first the full model. No? So this is variance inflation factor. This is to answer the question of Dom. This will address, this will see kung may multicollinearity, if we have multicollinearity. So VIF full model, I'll run this class. Okay, take a look at this. Okay. Now, the basis is that the variance inflation factors of your variables should not be more than 5. Okay? For other tests, yung medyo strict, it should be not more than 2. May mga ganun, no? Usually sa finance or economics, we can use it should not be more than 10 in order to establish whether there's multicollinearity. So in this case, class, wala namang more than 5 dito, or of course, walang more than 10. So there's no multicollinearity actually in our model. If you want to check, kunyari VIF and then model 4 lang, tingnan natin. So yung 4 lang natirang variables. Control Enter. Okay. 3 lang, no? So wala. No multicollinearity. So good thing for us, kasi pag may multicollinearity, we might need to address that. So far, even the full model class, there was no multicollinearity there. So it follows here that walang collinearity din dito sa model number 4. So that one we'll discuss when we go to diagnostics. Okay, thank you, Dom. Did that answer your question? Okay, good. Now, what we did here, class, was to do stepwise regression. Okay, there are other methods for stepwise. Meron tayong kasing forward at saka both. Okay, here I'm going to share this code with you. Control C. Let's run this class. And this is making use of kasi ang ginawa natin dito, class, manual, di ba? Actually, okay, merong mga functions na automatically iraran niya kagad yung stepwise, not having to do it manually. Because, class, imagine if you have 20 variables, tapos lumalabas dun ang daming insignificant. So, ibig sabihin, isa-isa natin i-manualize yun, matagal yun. So, there are functions like coming from the mass package, okay? Yung stepwise function na, okay, ito, step AIC. And here we're using direction, which is both. Okay, so let's run this. And you'll see, you might have a different solution here. So let's first load the mass package, and then let's perform stepwise regression using both forward and backward. And then the basis for this is AIC. Kasi kanina, class, yung basis natin ng backward natin is the p-value. Kung hindi umabot sa 0.05, tatanggalin natin yon. Okay, ito naman, forward and backward to combination. That's why it's called both, no? And let's see what happens here. We'll create this model called stepwise model and use this function is step AIC. And then, ang AI natin dito, class, not mod 1, kasi mod 1 has only one predictor, di ba? Si full model class. Okay? Si full model class, lahat ng variables yun, right? So, paggawa natin siya, class, ng stepwise regression. Okay, using the method both. Combination siya forward and backward. Okay, and let's run this. Okay. So mass package, all right. So we start here. Tignan natin, class, ha? Hourly wage regression 1, 2, 3, 4, 5, 6, 7. Ito yung original natin, di ba? This is the original method, original model natin. And the AIC, a KAIKI information criterion, is 1146.001. 0.02. Now, how does this work? It works by, okay, if you remove, for example, a variable, and if it will lessen, it will decrease your AIC, then so much the better. So, tingnan nyo to, class, ito. So, here you have 1, 2, 3, 4, 5, 6, 7. These are your 7 variables, class. The current AIC is 1146. So, if I remove any one of this class, the AIC will become 1255. So, sa AIC, the lower the better. So, pag tinagal natin class si education, ang mangyayari, AIC will become 1255. Lalong papangit yung model, di ba? Okay? So, among this, ang pinakamaganda is remove race. Yan, remove race. Magiging 1144 na lang yung AIC. So, it will decrease from 1146. So, ganun lang to class, tuloy-tuloy, no? So, next step, naging 1144 na yung ano, yung AIC natin kasi tinanggal natin si race ang tinanggal dito, no? Okay, wala na si race dito. So, kung wala na si race, again, titingnan natin. Kung magtatanggal pa tayo, okay, ang pinakamaganda si NAMDEP, 1143.9 kasi. Magiging, mababawasan yung AIC natin. So, okay, here, binawas si NAMDEP, wala na siya dito. Okay, 1143. Now, take note, kung 0.48, kung tanggalin natin si NAMDEP, sorry, no, take note here class, may plus at saka may minus. Okay, kasi both to pwede natin idagdag ulit plus or i-minus, no? So if I add number of dependents again, tinanggal natin kanina yon, diba? Magiging 1144. Pag i-minus natin si experience, magiging 1144.3. 1144.3 mas mataas na. So it looks like here wala na tayong matatanggal, no? Wala na tayong matatanggal na ano na variable. Okay? Kasi pag binawasan natin, bababa yung AIC. Okay? So, ano natira class? Education, experience, tenure, gender, and civil status. 5 class yung predictors natin. Okay? So, iba to sa model natin ng ano, iba yung model ng generate ng AIC kaysa yung p-value. Okay? So, that's the final model class. This is the final model. And let's see. Let's run. Ayan na pala yung stepwise model natin. No? Okay. And pinit na natin stepwise Okay, let me see this. Stepwise model list of 14. Yan na nangyari dito. View. Yan. Okay, tingnan natin class yung mga coefficients natin. Yan, 5. Education, experience, tenure, gender, male, and single status. Okay? Ito class. Now, let's run this class, no? Education, experience, tenure, gender, and civil status. Kasi iba siya dun sa ano, di ba? Iba siya dun sa kanina yung backward natin. Control Alt I. So I'll run a model mod AIC. Okay? And then LM, hourly wage. Sana pala kinopya ko nilang shift. Regress on. Ano yung mga kasama class? Education plus here. Copyin ko na lang to. Control C. Control V. Okay, comma, data is equal to wage. All right. Why am I doing this class? I'm creating a model where, which was the result of your AIC method. And let's see class kung may mga, kasi iba siya kayo sa p-value natin kanina, di ba? Sa backward natin. Sa backward natin, ang basis natin yung p-value. Ito AIC. Okay? Data is equal to wage. Sorry. Close. All right. If I run this now, okay. Tingnan nyo class, no? Si experience, hindi siya significant. Okay? Si civil status at 10%. However, yung sa AIC kasi, i-measure natin dyan yung information loss. So, even if experience here is not significant, pinasok pa rin siya sa AIC. Okay, sa model natin. Okay. Now, anong difference nila doon sa stepwise na yun? Okay, sa stepwise, yung una natin ginawa, yung backward na p-value, use that if you're really very particular about hypothesis testing. Okay? So, kung talagang strict tayo dun sa nag-hypothesize ka na dapat hindi pumasok yung mga variables na may p-values na less than 0.05. Okay? Yun ang gagamitin nyo. How about AIC? AIC is best used for predictive purposes. Kunyari, ang intention nyo is more of prediction. You're modeling and then you'd like to predict hourly wage, then studies have shown that AIC perform better than the p-value. Okay? So, both in general are accepted. Yung kaninang p-value natin, di ba? Yung p-value, yung backward natin na p-value, at saka yung itong AIC methods, they're all the same. They're accepted, depende sa purpose natin. Okay? So, ito class, let me share this. Control C. Another stepwise here. Control V. It's almost time class. Pa-extend na lang ng konti class, no? Thank you again for, I know you'll understand. Okay, so what are we doing here? Dapat full model to, sorry. Full model. Okay. Formula, full model. Okay. All right. Stepwise p-value model. All right. So we're using the step function. Full model direction is equal to both. Scope is equal to, okay, pinasama natin yung, let me fix this. Okay. And then my trace, I'll explain the formula next time na lang, no? I-run na lang natin to. Run. Okay. What do we get here, class? This is the result of our stepwise p-value model. Now, lumalabas pa rin, ganun pa rin, no? Criterion pa rin natin is AIC. So it still includes this one, yung experience, kahit na class, hindi siya, kahit na hindi siya significant. Okay, it's practically the same as the one that we did a while ago. Okay, now, okay, now let me just give an introduction, konting introduction ng class, no? Control Alt I. Next meeting, what we're going to do is we're going to reinforce our model. Nag-stepwise na tayo. Okay, this time we're going to do interaction. Kasi oftentimes, class, yung mga variables na to, okay, these variables, maybe they're interacting with each other. So we're going to discuss next meeting. Kasi yung possibility pa, what if yung education, no? What if education is not really linear? Baka pwedeng squared siya. So just quickly, let me just, wala yata dito. Let me see. Okay, hindi lang class ha. Sorry for the little extension. Kasi gusto ko lang i-bring out sa atin to ngayon. Okay. Let me just, okay. Okay, kasi ito lang ha. I just open this. Introduce lang ako konti class dito. What will happen, we will discuss next meeting yung ano. Pero let me just, asan na siya? This one class. Okay, take a look at this formula. Hourly wage regression, ito class, oh. Education times experience, tenure times gender. Okay, what happened here? Okay. As an introduction, share ko lang to, and then tingnan natin class kung anong mangyayari dito. Okay, and this will be the last. Okay, pakicopy siya class. Alright. So, ang interaction model natin, class, tingnan nyo, no? Next week, ano pa natin to, we're going to improve on this. Hourly wage regression, education times experience, tenure times gender, race times civil status, plus number of dependents. Let's see what happens here. Ay, summary pala, sorry. Summary ng interaction. Capital naman. Okay, there you go. Run natin. Okay. Now take a look at this class. Okay, hindi masyado maganda. Adjusted R-squared 37. Notice now your predictors class. Education, experience, tenure, gender, race, civil status. And then we have this one. Education times experience, tenure times gender, race times civil status. May mga value siya. And itong tenure, significant eh. Tenure times gender. Okay? Yung interaction class, ang mangyayari niyan, okay, ay ibig sabihin niyan, si tenure, okay, yung interpretation, yung association, yung effect ni tenure on hourly wage depends on the gender. So iba yung effect ni tenure on the hourly wage kung male versus female. Yun ang ibig sabihin niyan. Okay? And that cannot be captured by yung simple main ano lang natin. No? Okay, so next meeting class, we're going to go into so I'll stop recording now.